Dear students, I am Dr. Saroj Revankar from the Department of Mathematics, BMSIT, Yelahanka, Bangalore. Today we are going to discuss on polar coordinate system. Now when we say coordinate system, so what is first a coordinate is? Okay, any point represented in a plane. So if we have a plane, I need to represent a point here. So when I am representing a point, I have two systems, two lines, isn't it? This is one and the another. So two lines perpendicular to each other means they form a coordinate system called x-axis and y-axis, and that is the reason we write the point as the coordinates as x comma y. So any geometrical picture or a shape which are in the form of either a square, a rectangle, a hexagon or a triangle, isn't it? See, these are very easy to represent in terms of, it is very easy to represent in terms of coordinate systems which we have already learnt in 12th. The x-axis and y-axis, xy, that is called a Cartesian coordinate system. It is called as Cartesian coordinate system, and it is represented like this is x-axis and this is y-axis, and any point in general we take it as x comma y. This x comma y is the representation of the point P. So if this is a point, then its abscissa is the x coordinate, isn't it? And this is the ordinate we say, which is a perpendicular distance y, and this is the origin. Okay. Now here it is big. See, this itself shows a rectangular form. So the another name for this Cartesian coordinate system is rectangular coordinate system. But when in nature, when we come across different paths, for example, see the picture, you can see a plane. See, is it a straight line? No, it's a curved form, isn't it? So the path of a motion of each plane in this formation can be tracked with the radar, and their x, y, z coordinates relative to a point on earth recorded as a function of time. What do you mean by this? So we have a plane in a curvilinear form, curved path. Okay. So in order to understand its each position point, okay, in coordinate system the equation becomes clumsy. So in order to avoid that, we go to a new coordinate system known as, polar coordinate systems. See, it's not only just a plane or even a roller coaster. That is very interesting, right? When you sit in a roller coaster, it rotates. How is the experience if you have tried it? It is breathtaking, isn't it? So in that case, how perfection it should be when they are constructing a such roller coaster, or how can we determine its position or acceleration? We need to know with what velocity it is going up, its acceleration, everything we need to know. So in order to construct a roller coaster, what kind of maths is going into it? It's a spiral form, isn't it? So it will be like this form. So when it is in this form, it is very difficult to find the position of any point in the Cartesian coordinate system. So we go for a system called polar coordinate system. So how it goes? A particle, for example, just I take even in a physics or electronics, any motion we consider in terms of a particle. So a particle moving along a curved path undergoes a curvilinear motion, isn't it? Already in 12th class you have gone through, you have understood what is polar coordinate, like how we represent, how we use the polar coordinate system. As already you know, x is equal to r cos theta, y is equal to r sin theta form, isn't it? So, that is what we are trying to understand it now in detail about the polar coordinate system. So, here how we take a position is the point P, okay, means this is the pole, a starting point, and this is a position of a point, any point here P, and this is a particle which is traveling, okay. So, the polar coordinate system is a two-dimensional. So, what do you mean by two-dimensional? There are two coordinates, isn't it? What are the two coordinates here? So, coordinate system is a two-dimensional coordinate system in which a position of a point is described by its from a distance from a fixed point and its angle from a fixed direction, and that is what we have. So, here we have a polar coordinate system, okay. So, how we represent? We represent it, if I take, so as this is what, just two lines we have. Now, when it is polar coordinate, what are the coordinates we have? We have r comma theta. So, r comma theta, what is that r? It is a distance of a point P, distance of a point P from a fixed point, okay. I take it that point as O, and which is called as a pole. The distance of this point from a pole is nothing but, okay, the distance from a pole. This is a radial distance r, which I was showing you here. So, this is the r, and we have a path. So, any point on a path. So, this is r. So, whenever we have a distance, okay, what is that? It is changing its position. The particle is changing its position. That means what is changing actually? If it is going away, what is changing? The r is the length of a point, or the distance between the pole and a point is changing. And when it is moving in a curvilinear form, what is that changing? The change is the angle theta. Now, I want to represent this coordinate system in terms of Cartesian coordinate system, and that how we do? X is equal to r cos theta and y is equal to r sin theta. How is that? So, this is a point, draw a perpendicular, okay. So, when you draw a perpendicular, okay, this is the point P, and if you join it, okay, if you join to the pole, then this fixed line is normally represented as x axis, and this will be considered as y axis, okay. This will be considered as y axis, and this is the angle theta. And we know when there is an angle, what helps us, which functions help us to know the perpendicular distance or the base height. If we want to know, we use the trigonometric ratios. So, what trigonometric ratio can be used here to know the x coordinate distance? This is x and this is y. So, r and theta are in polar coordinate system and x, y are in Cartesian coordinate system. So, how the relation is? If I take this is x, this is y, this is theta. So, what is sin theta? Sin theta is equal to opposite by hypotenuse, that is y by r, isn't it? If I take it as m, that is nothing but p m upon o p. So, from this we get y is equal to OP sin theta, or that is nothing but r sin theta, isn't it? And that is what we have here, y is equal to r sin theta. If I take in terms of cos theta, so cos theta will be, so cos theta will be adjacent OM upon OP, and that is nothing but x by r. So, x is equal to r cos theta, y is equal to r sin theta, and then transforming in terms of polar coordinates by squaring and adding x square plus y square is equal to, see, x square plus y square is equal to r square sin square theta plus r square cos square theta. So, if I take r square common, it becomes sin square theta plus cos square theta, and that is nothing but 1. So, it becomes r square, and we have r is equal to under root x square plus y square. And if we divide them, then we get theta is equal to, how is that divide them means, if y by r is equal, sorry, y by x, isn't it? So, if I take y by x, it is y upon x is equal to sin theta by cos theta, which is equal to tan theta. So, theta is equal to tan inverse y by x, and that is what we have here. Theta is equal to tan inverse y by x. So, what are the advantages of polar coordinate system? Why we need a polar coordinate system? It suits circular or rotational symmetry, means it is applied where we have a circular or a rotational symmetry. So, the equations of circles, spirals and sectors are simpler in polar coordinate system compared to Cartesian coordinate system. Also, simplifies problems involving circular regions or boundaries where there is a changing, varying boundaries. We can apply the polar coordinate system. Okay. So, what is that? It helps us a complicated equations like finding a area of a circle. For example, if we have a circle, y is, see, equation of a circle is what? X square plus y square is equal to r square. So, if I take y is equal to under root r square minus x square, this represents a circle. So, instead of evaluating integral or the area using this formula, we can just use double integral, okay, in terms of 0 to pi by 2 and 0 to a r dr d theta, simple equation to find the area of a circle. So, this is how it helps us to simplify the complicated equations or the complicated integrals to a simple form of integrals. Thank you.